All right, so first one, I'm going to try to walk you through the shortcuts that I used when I did this, so that way you can see kind of how easy some of these problems were. This first problem, this is just a Pythagorean identity. It's the one that says 1 plus tangent squared is secant squared, so I replaced it. Secant squared is 1 over cosine squared. That's what it is on the property sheet. It says it's 1 over cosine because it's a reciprocal. And then when you multiply, the cosines cancel and you're left with 1. So that's the right and left side. I saw a lot of people they multiplied this through and then they converted them to sines and cosines, fine and dandy, but that's the idea, okay? All right, moving on, number 2. Okay, number 2. On this one, this is the one that caused probably the most headaches for most people. Here's my shortcut for how I did it. You had to multiply by the conjugate of the bottom. So you're seeing it here. When you multiply the bottom, you get 1 minus sine squared. The top you don't actually distribute. So the reason why is that the bottom will convert. 1 minus sine squared is a Pythagorean identity. It's actually cosine squared. You're actually seeing me put it over there. You can see cosine squared. So that's replacing the bottom. I didn't even multiply the top. So in fact, let me scroll over so you can see that. I just canceled out the cosines on the top and bottom. And then the idea is that what I'm left with is 1 on the outside minus this fraction, which is not even a fraction anymore. So I can distribute the negative sign. And this is what I'm left with. And the 1's cancel each other out, so you're left with sine. So it was meant to be short. That was probably the longest problem on the test. Now, the next one. For some reason, people were going way overboard. Way past what you should do. And I had some people they were trying to throw in reciprocal functions and trying to throw in I think somebody even tried to do a Pythagorean identity, way too much stuff. What you have to do is just do this little rule where you put the cotangent on the bottom of both, because that's called the law of division, that you can divide both. Okay, like this. On that side, the cotangents cancel. That was kind of one of the main steps, so that's just sine. This side, I left it. So what I did is I changed cotangent into cosine over sine, and then I can flip it over and do a reciprocal, because this is a number over a fraction. So you're allowed to do a reciprocal. When you do that, the cosines cancel. Because the sine will technically, when I flip this over and I multiply it to the top, the sine will actually go to the top. So the cosines will actually cancel, leaving me with sine plus sine, which is 2 sine. This one is the most commonly missed question. I had a lot of people putting cosine times sine because they didn't know how to flip it. They were getting rid of numbers and stuff. But it was incorrect math. All right, the next one, 15. I just went 45 minus 30. I think most people did that. That was the subtraction formula. So you're plugging in what the sine is of 45. You're plugging what the cosine of 30 is. Sine of 30, cosine of 45. That's just from your unit circle. You can see those answers. When you multiply, you get root 2 over 4. This gives you root 6 over 4. And then when you subtract it across. And so it's just root 6 minus root 2 over 4. When we did all the sine and cosine problems, they all had the same answers. That was pretty much what the answers were every single time. Tangents. I converted it to 255, or 255, sorry. 255. And this is the part where I differed. I did it 225 plus 30. I saw some people did, I think it was 300 minus 45s. There were some other ones where I think some people did, what was it? 210 and 45. I saw some of that. There were some other ones I saw in there. There were some plus 60s and stuff. But anyway, what you have here is the tangent addition formula. So it's tangent of the first, tangent of the second over 1 minus the 2 tangents multiplied together. This answer, you had to use 225, is a 45-degree triangle in this third quadrant, so it's just 1. Tangent of 45 is 1. But tangent of 30, you had to actually use the units, the special triangle. Tangent of 30 is 1 over root 3. And this is what I was looking for. I was looking for this or this, because I just multiplied everything by 3 to get to this part. But some people were going way overboard. They were trying to do some weird fancy stuff. You didn't have to. All right, next page. All right, next page here. This problem, I converted them all to degrees. And then the idea is that this whole mess is the sine formula when you subtract angles. It's the sum and difference formula for sine. So you're subtracting 45 and 75. You're subtracting them. That gives you 30, and then you can just rattle off the sine. This is the part that really gets people. They're like, well, Ward, you found sine of 30, but what's cosine? I didn't care. This formula, this whole thing, is the sine formula when you subtract numbers. Subtract angles. So then I'm going to this, and then that gives me the 30, and then I can just use the unit circle to rattle it off. I don't think too many people miss that question.
I know you counted mine right then, right? Root 4 over 4.
Yeah, root 4 over 4 is still half.
I definitely had something.
Square root of 4 is 2
different.
over 4.
And
Yeah.
just got a question mark.
Keep going.
Yeah, what?
Like I did something completely different.
Different, but you still got a right answer.
Yeah.
Yeah. There's different
Just
ways
have a
to do it.
question mark.
Yeah, I saw some people like they converted 75 into like 30 and 45 and they did like individual problems separately and they
That's
plugged
it.
them in.
Yeah, that's kind
I saw there was like multiple people that did it. That was way too much work.
Yeah, I didn't
Well,
know how
maybe
to
you
find
shouldn't put that much work
75.
into it for us.
So I didn't. I was teaching how to do that on the practice guide. All
Okay, I
right.
have a question.
Okay. What?
How did you find like 75? Like, okay, so like I don't know. I didn't know how to find the 75.
How you convert it? Take 5 times pi times 180.
No, like I got that, but like, cause like it's not like one of the things on the pie chart.
Oh.
So how did?
So yeah, so when you put it back to this thing, it will get
Yeah.
rid of the 75.
What?
So when you plug it into
It
the
does.
subtract.
It does.
Okay. All right. I know what you're saying,
It will
but
overwrite.
the way that you did it, yeah, you had to break it up to 30s and 45s. Yeah. All right, 7. You had to draw this. This is the part that most people got wrong. It's doing the whole 40 and 41, and this is where we're. That's one of the questions I had earlier. You do the Pythagorean theorem. This squared, this would have been x. X squared plus negative 40 squared, this has been positive by the way, equals the 41 squared. So x squared plus negative 40 squared is the 41 squared, because the 41 should be your hypotenuse. How I know that? This is the hypotenuse, this is the opposite. And then when you do that, this on a calculator, if you actually type that in, that will give you a positive 1600. This will give you a positive 1681. And when you subtract this over, you get x squared equals 81. And then you can take the square root of it, which is the number I want. I want that one, not 81. I had some people put 81. I want 9, the square root of it. And then I had some weird questions, like some people would give me 57s.
Yeah.
Because the only mistake people made there, and why you only missed a point, was you did these two squared added together, and you set it equal to that wall. That's not the hypotenuse. That one is. So you had to make sure that the 41 was the wall by itself. All right, but anyways, when you plug them in, here's your double angle formula for sine, double angle formula for cosine, just pick one of them, double angle formula for tangent, and then you just had to plug these values from your triangle in. And that's all I wanted. You did not have to simplify. I said you didn't have to. You had to show me the formula and plug in the values from that. Okay? And this is where you could say, now a lot of people went further, fine, you didn't have to, and I was checking to see if you were kind of right and stuff. All right, next one, 8. That is a double angle formula. In fact, if you didn't recognize it, it was taking sine with 2 times whatever the angle they were using. It's the sine double angle formula, this whole thing is. So they're doubling 22.5, that makes 45, and the sine of 45 is that, and that's your answer. So, that's the double angle formula. Okay, you didn't have to type in decimals and stuff. It's the double angle formula from your property sheet. Okay, it's the one I just used in problem number 7. It's this one right here. So that's why it's equal to this thing. I was just using it. Okay, number 9. This is the problem that butchered some people on this test. Like, it really hurt. I just simplified this side over here. That's all I did. I just simplified this side and I made it work. So watch how this works. This is the double angle formula. It's not cosine squared. It's cosine 2 theta, and I warned you that on all the test days. So that's a double angle. This is the double angle formula for cosine. That's like the first one. Okay? Then it's over cosine squared. What I did next is I divided both sides by cosine squared. I just separated. That's the law of division. The first one simplifies to be 1. The second one, if you take sine divided by cosine, that's tangent.
But you never told us that was true if it's both of them
Or
straight.
no bathroom.
We have
You
that.
never told us
So,
that.
question?
No bathroom.
Yes. Moving on. Next one. The half angle formula. They're taking 75, so that's half of 150. So what you're doing is you're doing the half angle formula for tangent. There's 3 of them. I just picked this one. This is the one I like. And you plug the 150 in. And that's some people were using 75s. You have to think about the number they cut in half to get you to 75. So it was 150s, and then I plugged in my answers from the unit circles, what 150s were. Okay? All right, 11. You had to do the triangle, and then do the half angles in here. And you had to use your half angle formulas, and that's why I use this one down below. Again, I was looking for which one you pick. A lot of people pick the different ones for tangent. I had a lot of different answers for tangent because they use different ones. But the other ones up above, I was looking kind of, did you even have it set up correctly? Okay? 12. This one, you had to find the missing angle, which was the 56, and the 111, and then you had to find the missing wall. Because what I did first is I did sine of 12 over 7, sine of this angle over 28, cross multiply and divide to get this number, take the inverse sine to get 56, that's this angle right here across from the 28, so that's how I set it up. You subtract from 180 to get the 111, and then now I can find the wall across from it. And the numbers all should make sense. Okay? Alright. 13, the Leaning Tower of Pisa. It's 84 feet. Now, if you didn't search it online, but how you do it, sine of the 45 over its opposite wall, sine of 50 over its opposite wall. The most common mistake I had, so many people are getting wrong numbers here. Like they couldn't subtract the triangle correctly. You get the right angle. I had that. Okay?
That's hard sometimes, Ward.
Yeah. The calculator. Alright. 14. This one really got people. Now, there's a bunch of people I had to probably put okay on it. I was grading them. I was going through and I was marking things wrong, like, oh, that's wrong, that's wrong. And then I got through and I was about 3/4 way through your class, and suddenly I went, you don't have to have the triangle exactly the way I have it set up. Like I was just like looking at the triangle and it's like, I was looking at mine was like 58 and 86, right? And I saw some people have the numbers in different spots, but I was like, oh, wrong, that's wrong, that's not in the right spot. And I was like, they don't have to be in the same spots. Your triangles could be shifted and rotated. So I had to go back and just put okay. So you're probably seeing a lot of that. Because I think a lot of people had like the 58 on the top. It was a stupid mistake. So I went back and I kind of fixed that. But anyways, the law of cosine is 4 squared, 6 squared, 7 squared, that. You multiply these together, you subtract these over. This number is attached to cosine. You have to divide that number over. You can't add it or subtract it. Once you divide, then you can take the inverse cosine and get 34. Once you have that 34, now you can just do the law of sine. 34 over 4, sine of, I think I did the 58 first, so I did sine c over 6. Cross multiply and divide, take the inverse sine and get 58. Then you subtract from 180 and you get 86. A lot of people were getting like some weird numbers. I had a lot of people give me like 89s, which is not right. I wonder if you're just rounding wrong. Alright, number 15. Do the law of cosine. V squared is equal to the 2 other walls squared added together minus the cosine angle between. These numbers, yeah. This is the part people got wrong because they weren't multiplying these together to get to this. They were trying to like add or subtract these 3 numbers. That's where you went wrong. You had to like do these numbers and then multiply this thing so you could subtract those together later to take the square root of it. That's where some people went wrong. And then to figure out the angle, I was looking for this angle in the triangle. It's the angle the boat could have originally taken from the pier to get where they're at now. So they left the pier. This is the pier up here. And they left the pier and they could have just taken this angle. They could have taken a 32-degree angle. Now the other options you could have done for 32, you could have done 122 or east 32.4 southeast or south 57.6. Because again, how I'm getting all these numbers, going directly south is 90. So I can subtract 32.4 from 90 to get that 56 number right here. Or if I'm going from north down to this line, that's 122. Because north is 90 added onto that. So that's just different ways to do it. And again, how I found the sine, or how I found this 32 is I used the law of sine. I had a lot of people trying to find the other angle. A lot of people give me the angle where the boat is sitting. It wants to know the angle the boat could have taken to get to that spot, not to get back home. So that was a difference. All right. Well, there you go. Okay. That's it for today.
To Prop 14.
Yeah. Those numbers I was looking for. And if you had an okay, it was because I was going through it so fast and I nearly marked it wrong. I had to put okay because I wasn't thinking clearly when I was checking that one.
It's right here. It's in your hand.
How many points is that worth?
I think it's 4.
It's 5. Is it 5? Yeah, because you counted
7.
5.
7.
It's worth 7
7.
points.
Most people, like, they had it set up where they tried to do law of cosine or sine, or they tried to do Pythagorean theorem or something like that. At least you got some points for attempting to see what type of triangle it was.
Like my size, I'm like, what muscle do I use?
Alright, but there you go. Alright.